welcome back students. This is lecture number 2, and in this particular video we are going to discuss about distance and displacement, how these two quantities are different and how they are related to scalar and vector quantities. All these things we are going to discuss. What is the difference between distance and displacement, and what are the similarities when they can both have the same magnitude, that also we will check. So in this video we are going to discuss one more term, distance and displacement, that is associated with your motion in one dimension. So let's start with distance. So if you go to the theoretical definition of distance, it says that total path traversed by a body. The total path traversed by a body is called as its distance. Clear? Let's take an example. Suppose a body X is traveling like this and again comes back to this, its initial point. This was the initial point for X. If after this also it goes like this, then what we have to do, we have to measure one time the whole path, another time this one path is to be added again. That is the meaning of total path traversed. As much as distance it will travel, that we have to add, and it comes out to be the distance traveled by that particular body X. So theoretically distance means the total path traversed by a body. What about displacement? If the same example I take, same body I am taking, and I said to you that after completing one round it again started from here and like this and it stopped here. Clear? So I won't take full round because it has come back initially to its current position, initial position. The current position is its initial position, and after this it traveled this much more. This also I won't take. Why? Because displacement depends only on initial and final point. This is the final point and this is the initial point. So what distance I will take? I will take a straight distance between these 2 points. This is displacement. This distance, the straight distance, is called as displacement. This is the difference between distance and displacement. It means that displacement is just the distance between initial and final point, or you can say the straight distance between the initial and final point is called as its displacement. This is the distance difference between distance and displacement. If I talk about distance, same example. So total path traveled, one round full, then after this again this one I have to add. But if I take the displacement of X, I have to just note what is the initial point and what is its final point. This was the final point. So straight distance I have to take, so that the answer that I will get, the result that I will get will be the displacement. So from here the distance comes, the definition comes that displacement is the shortest distance between its initial and final point. Straight distance means short distance only. If you are taking a straight distance, it means the shortest distance. Okay, so displacement is the shortest distance between initial and final point, whereas distance is the total path traversed by a body. What should be the unit of displacement? Same as distance. Why? Because this is also distance. In a way we can say that this is the shortest distance. The word is coming distance here. So they will have the same unit. Here also it's meter, centimeter, or other smaller units you can take. SI unit meter and your CGS unit centimeter. This is the difference between distance and displacement. Another point of difference between them is distance, as you have seen, does not depend on direction. If you are taking a shortest distance, it means definitely you will consider a direction. Without direction, how can you take the shortest distance? It means displacement is a vector quantity, and here distance, since it is not at all depending on the direction, so I will say it's a scalar quantity. So let us take an example for more clarification. If I want to write distance, so I will just write, suppose for a body I am writing 340 meters. So this is for distance. But if I write 340 meter towards west, then definitely this is a displacement. So in this way you can see that a difference between distance and displacement. Displacement has magnitude, displacement has magnitude as well as direction. Why? Because displacement is vector quantity. Vector quantity has both magnitude as well as direction, and distance only magnitude, since it's a scalar quantity, or we can say that since it only has magnitude, so it can be categorized as a scalar quantity. So this is the difference between distance and displacement. The similarity was the units are same. Let us discuss some more important points regarding distance and displacement when considered together, if we are considering it together. See, point number one for it, distance and displacement. For distance and displacement, they may have same value. They may have same value, in which case, suppose point A and this is point B. So a body traveled in this way. A body has traveled in this way, straight distance. So if I take out the distance, suppose the total distance from here to here is x meter. Look at the diagram very carefully. The distance between A and B is x meter. So what will be the distance traveled? Distance traveled will be equal to x meter, because distance is sum total of path traversed. So this path was traversed. This path was traversed between when a body traveled from point A to point B. So the distance will be x meter. What about the displacement? Now from the definition also you can take out the answer. Displacement depends on initial and final point. Initial and final point. So initial point is this, final point is this. Take out the shortest distance, it will again come out to be x meter. Clear? So this is one of the case where distance and displacement may have the same value when the body is traveling in a straight line. Motion one dimension means traveling in a straight line. So when a body is traveling in a straight line without any curves, without taking any turns, so at that time distance and displacement will have the same value. This was the point number one. Now let us discuss point number two. Second case, distance is always positive. If you take a distance, it will be positive, but displacement can be positive as well as it can be negative. It can be positive, it can also be negative. How? See, suppose this is body A. So it went like this and then reached at point B. From A, body traveled and reached to point B. Then from here the body traveled like this, again back to point A and went further to point C. First it went like this, then it returned, and then it went like this and stopped at point C. So let us take the distance. Suppose this distance is x and this is y here. A to C y and A to B x. So if I take the distance, it will be x plus y. X plus x then y. This is the distance traveled, total distance traveled. If I talk about displacement, so displacement depends only on initial and final point. This was the initial point, point A, and the final point is point C, and A to C is y meter. Suppose unit is meter, so it's y meter. So how I will write displacement? I will write minus y. Why? Because in displacement we have to consider the direction. If this is taken as positive, here it is taken as positive. In case of displacement, now since you are going to the opposite direction, you have to use minus. So displacement can be minus as well as it can be positive. In the first case it was positive like distance, but displacement can be negative. But if you talk about distance, if you're calculating distance, it will always come out to be positive. Here x plus x and minus y was not taken. Why? Because distance has nothing to do with direction. Since the distance has nothing to do with direction, so it is taken as plus y. But what about displacement? This was taken as positive direction, now it is going in the backward direction or opposite direction, then we have to take direction as minus. so it will be minus y. So displacement, another point is displacement can be negative also, but distance is always positive. Now point number third is displacement can be zero. Displacement can be zero. For a body, a displacement can be zero, but distance won't be zero. If you are calculating distance does not equal to zero. Let us take example. Again the same example, point A, point B, body traveled from A to B and then returned back to point A. So this was the initial point, this was the final point when it traveled from A to B. Then again it returned, so that this time this is initial point, this is final point for the distance. So if I calculate the distance, let us take it as x meter again. So it will be x plus x. It will be x plus x. But suppose I talk about displacement. So if I talk about displacement, I have to check the initial and final point. So A was the initial point, body went to B, again came back to A. So what will be the outcome of initial minus final or final minus initial? It will be 0. Body has traveled, but the displacement came out to be 0. Why? Because displacement is only dependent on distance final minus distance initial. In this way it is dependent. Final point, initial point. It depends only on final and initial point. So initial and final point are same. So what we can write? We can write that displacement is 0. But distance won't be 0. Distance will come out to be 2x. Why? Because again the same reason, distance has nothing to do with direction. If you want to show it by sign convention that how displacement came out to be 0, let's see. Suppose I take in this direction as positive direction. Sign convention means one of the direction you can take by yourself, you can take it as positive. I will show you the both way. Suppose you are taking direction from A to B as positive, then what will happen? For displacement it will come out to be x. Again it returned back. Now when it returned back, it changed its direction, so it will come out to be minus x. I hope it is clear. In this direction distance is positive, the distance that you are taking is positive, and then when it returned it changed its direction, because displacement depends on direction. Do not think that why we are not using that concept for distance, because distance has nothing to do with direction. But in the case of displacement we have to talk about direction. So suppose this direction is taken as positive, so I wrote plus x, but when it returned back it changed its direction, so I have to write minus x. Overall 0. Again, if you are taking sign convention in a different way, suppose you are thinking that A to B I will take as negative direction. So let us take it. So displacement, here I write displacement is equal to, here to here you are taking as negative, so you will write minus x. According to your new sign convention, suppose you are taking another way. So from A to B you move, and while moving you took it as negative direction, not positive, negative direction. So this distance is minus, but from B to A you returned back. Now when you return back you have to change your direction. So change direction means now it will be plus x. Again the answer will come out to be 0. Clear? So these are the 3 points which you must know as a point of difference and similarities for distance and displacement. And from these points you can also take out the difference between distance and displacement, which is a common question regarding distance and displacement, that what are the point of differences between distance and displacement and what are the similarities between them. So from here you can take out all those points. So first point that we discussed was distance and displacement can have the same value, they can give you the same value. Second was distance is always positive but displacement can be negative. Third point, displacement can be 0, while for any body distance won't come out to be 0. I'm not talking about still body, I'm not talking about a body which is at rest. For a moving body, these are the points for a moving body. So when a body is moving, displacement can be 0 but distance won't be 0 for that body. I hope these 3 points are clear. So this was all about distance and displacement, which is an important term for your motion in one dimension. So I hope this point is clear to you. In the next video, we will come with another point like your velocity and speed. What are the differences between them? Instantaneous velocity, then your acceleration. Many points are there which we have to discuss. So in the next lecture, we are going to take those points. So till then, clarify your concept regarding distance and displacement. So keep growing, keep studying. Thank you.